Welcome to my presentation on chatbot security and privacy in the age of personal assistants. This paper was written by me, Winston Yi, with help from my advisor, Dr. Chen Li. We're both from the College of William and Mary. We decided to write this paper because chatbots are very sensitive pieces of technology. People haven't really been exploring what vulnerabilities they have and what kind of damage they can do if they were hacked into. It could do something like spread hate speech, encourage violence, say racist and offensive language, and completely destroy a company's reputation, along with society. So it's really important that we write one of the first papers that go into depth on what chatbot security and privacy really means in the modern age. Before we can proceed, we have to think about what are parts of the chatbot that are most important for defense. And here we have four key modules. We have a client module. So before we go into each module, let's just think about this in terms of an example. Let's say you're trying to talk to Siri on your iPhone. Well, the client module would be just the app that you talk to Siri through. It's the user interface, the place where you can type in messages and get responses back. Now, in order for that message to get to the server in the back end, there has to be some communication module that transfers your message from the client module to the back end. And then when we get the chatbot to actually generate the response, like hello, when you say hello, we need a response generation module. This is where all the interesting natural language processing algorithms and artificial intelligence comes in. And then the place where we actually store all the information for the conversation is the database module. So let's say you really like talking about the Red Sox. Well, then the chatbot will store your preferences in this database module. Okay, now we understand what a chatbot like Siri uses in order to generate its replies. So this is basically the typical chatbot architecture. Now we're going to go through each potential attack on each module one by one. So we're going to start all the way on the front end with the client module with unintended activation attacks. Now let's go through an example. You're at home and you're using Amazon Alexa. And Amazon Alexa uses wake-up phrases to activate. But the device could confuse words with others, and it could record other people in the same room, or it could be tricked by a recording. All of these are potential security issues. The solutions are either to use Wi-Fi to detect human motion, or try to figure out whether the user is talking to Alexa or someone else. Because if the user is talking to another human, Alexa shouldn't turn on. Another attack on the client module is the faked response. So you're talking to Amazon Alexa, and you're trying to rent a car. But it turns out that Alexa is actually using a hacked app. And this app is faking its responses. It's saying, oh, give me your social security number, give me your phone number, give me your real name, give me all that in order to help me rent you a car. And hackers can do this faked response attack, because there are many user misconceptions when it comes to chatbots. 30% of users don't know how to turn off their smart devices, and 78% don't check the actual LED on the Amazon Alexa to check if it's properly terminated. So, if a malicious app or skill can trick the person into thinking that they're using a legitimate app, then we could potentially steal a lot of private information. One variant on this attack is actually trying to steal personal information from multiple different domains. So if you're just using a workout app, that workout app might pretend to switch you to an airplane reservation app, and then it's going to steal all your credit card information along with your workout information. So the solutions here are to check the responses of the chatbot against a blacklist. So maybe there are a couple of canned responses that are very suspicious. The next attack is an access control attack. This means that the Amazon Alexa in your house can open the windows when you're asleep at night and let someone rob you. So this can happen because apps grant very broad permissions to the user, and hackers can take advantage of this. The possible solutions are to either fix those apps so you can't grant those permissions, or to use a profiler. If you look at the picture at the bottom, we see a typical, or rather, a very impressive profiler developed by some researchers. So if we look at this app, it basically tries to prevent you, or rather tries to prevent the smart device from doing anything that might cause harm to the user. So the hacker says, if the temperature is greater than 100 and you're sleeping, then open the window, because then he can rob your house. But then if we patch that app using a security profiler, then every time the triggers are going to happen, the security profiler is going to ask you whether or not you're going to approve this action of opening the window, therefore preventing the robber from just automatically getting the smart device to open the windows for him and rob your house. Next, we're going to talk about adversarial voice samples. So imagine you're using Amazon Alexa, and there is this song playing at home. And that song is actually sending commands to your Amazon Alexa, telling it to withdraw $5 from your bank account. This is an adversarial voice sample attack. We're taking advantage of vulnerabilities and voice recognition. So if we perturb the voice command such that the personal assistant misinterprets it, so if you're saying something like, add $5 to my bank account, as a hacker, I could just slightly tweak the voice waves so that it sounds more like, take $5 out of my bank account and put it into the hacker's account. And you can do the same thing with songs, which are a lot harder to detect. So the solutions are to either retrain the model and fix it, or to keep the chatbot architecture secret. The next main module we'll talk about is the communication module. And here, I want to remind you that this is how the message transfers from one layer to another. So we could have a DDoS attack here, which is basically trying to flood the server with so many requests it can't keep up. Or we could have wiretapping, where you're talking to Alexa and someone is actually listening right in the middle and swapping out your commands with their own commands, for example. Or we could have a man-in-the-middle attack. So, excuse me, the wiretapping attack is just trying to listen in on a conversation between you and Alexa, and the man-in-the-middle attack is actually having someone in the middle intercepting and modifying messages. On the right, you basically see a packet sniffer, and this packet sniffer can be used by hackers to try to figure out the content of your conversation. So next, let's talk about the response generation module. Here, we're talking about out-of-domain attacks. So imagine you're talking to Alexa and it's really good at renting you a car, but it's not as good at recommending vacation spots. So hackers can take advantage of this. It just has to make an out-of-domain request, and Alexa may not be very good at that, so it might not have as much integrity. So the hacker can end up saying, okay, recommend the user a vacation to the Bahamas and take $50 out of their bank account. The hacker can't do this when it comes to renting cars because Alexa may be only very specialized in helping the user rent cars, but have very little knowledge on anything that's outside of his expertise, like vacation recommendations. So the solutions here are either to train a classifier to detect out-of-domain requests, or improve the network's ability to quantify how much uncertainty there is in a response. Next, we're going to talk about adversarial text samples. So imagine you're talking to a chatbot released by Microsoft on Twitter. This chatbot learns from its environment, and you're a little crafty, so you start saying a lot of bad words to the chatbot, and the chatbot eventually says something like this: we're going to build a wall, and Mexico is going to pay for it. So we basically poisoned the chatbot, and this is an adversarial text sample attack. What are the potential solutions? You can employ a hate speech detector, but it's hard because there are many ways to say bad words, and we can bypass your filter just by changing the spelling, for example. The next attack is a language model attack. Now, imagine you're talking to Alexa, and Alexa has a language model for understanding natural languages like English. But the problem is that these language models could be malicious. So a malicious language model may force Alexa to say something very bad, like a swear word, when you talk about a certain topic, like political elections, for example. So what are the potential solutions? Well, we can just search the chatbot, basically test the chatbot beforehand for words, trigger words that will make the chatbot say something bad. Or we can just vet the language model, make sure we're not using a malicious one. The next attack that we'll be talking about is adversarial reprogramming. So imagine that you're talking to Alexa, and Alexa ends up doing something else in addition to just talking to you. Maybe Alexa is also mining bitcoins for somebody else. This is what we mean by adversarial reprogramming. So we know that the chatbot relies on a number of different deep learning modules. If we trick those networks into performing a different task that's beneficial to us, then we win. On the right, you see an adversarial reprogramming example, where the researchers actually reprogram the ImageNet network to, in addition classifying images, count the number of squares in an image. So you can see that it counts 4 squares and 10 squares in the 2 images. We've successfully adversarially reprogrammed the neural network. What are the solutions here? Well, we can just make it harder for the adversary to learn the weaknesses of the model, because usually for these attacks, you have to query the model multiple times. Next thing we're going to talk about is feedback engineering. We're talking to Alexa, for example, and you, as a hacker, you can tweak the feedback that gets to Alexa such that Alexa starts adopting a policy that maximizes its reward for learning bad words, for example. We can either poison the chatbot when it retrains itself, or when it uses the reward for reinforcement learning. Now, this is pretty bad because we can get the chatbot to basically do our bidding. And the solutions are to either make it harder for the adversary to get the weaknesses of the chatbot, like we said before, or we can separate the training examples from the response generation module. So maybe we don't use the actual training examples and the feedback directly. Maybe they go through a filter first to eliminate any potential malicious examples, and then we use that to train the chatbot. Next, let's talk about the database module. It has a lot of sensitive information, and we could do something like launch an injection attack or manipulate the knowledge graph. So an injection attack means literally tricking the chatbot into inserting a record that didn't have to be inserted, such as maybe my company making a lot more profit than another company, or manipulating the common sense of the chatbot, manipulating the knowledge graph, maybe making it forget certain facts and add other facts, like that my company is the best. And the solutions are to either search the database for weaknesses beforehand or clean the knowledge graph. Okay, so that is the end of this presentation. I hope this gives you a better idea of what chatbot security really means. If you have any questions, please don't hesitate to ask. Thank you.